Hello students, this video is about electrolytic cells. So, quick review. We have this umbrella term called electrochemical cells. And we have talked about voltaic cells, or a synonym for that is galvanic cells, which I think of and you probably think of as your standard battery. We learned that in a voltaic cell, chemical energy is converted to electrical energy. These have spontaneous reactions and positive voltages. Now, today we're going to learn about electrolytic cells, which are the exact opposite. We go from electrical energy to chemical energy, which means we require electricity. These don't make electricity. We got to plug this into the wall and use electricity to make chemicals. They're non-spontaneous reactions and they have negative voltages. The five constants, however, are all the same. Gain of electron reduction still occurs at the cathode, loss of electrons, oxidation, anode. Electrons flow anode to cathode, anions migrate to the anode, and cations swim to the cathode. Okay, so we're really talking about, the first demo here anyway, is called electroplating. So it's an electrolytic cell, and the process is called electroplating. So here's how it works, electroplating. Okay, so there's our three characteristics. First one, we have a power supply. So this is plugged into the wall. We're using electricity to make chemicals, okay? Second thing you need to know here is that on that little power supply, the negative post on the power supply is always attached to the thing that we want to pump electrons to. In other words, if we want to plate this key with copper or chromium or gold, I have to attach the key to the negative post on the power supply. That'll make it the cathode. Electrons come out the negative, okay? And the other one, of course, is the anode. Okay, so if we go and list all of the entities we have here, I've got copper 2 ion in the solution, and copper 2 is a blue ion, so that's why the color of the water looks blue. I've got some acid in there, I've got some sulfate ions, water, and then this carbon rod. If I go check my chart, I find that my strongest oxidizing agent is copper 2, and the oxidizing agent is reduced, gain of electrons reduction, cathode, right? And I also know in this case that my strongest reducing agent is water, and that's oxidized, loss of electrons, oxidation occurs at the anode. Okay, so on the chart it looks like this, and you can tell just by looking at that the OA is below the RA, so this is non-spontaneous. All right, now I'm going to do my reduction half reaction. Okay, so I've got my copper 2 plus 2 electrons goes to copper solid. I write down my voltage, so I just copy all of that right off the chart. Now my oxidation half reaction, of course, I have to flip what it looks like in the chart. So I flip it to my oxidation equation. I flip the sign, so I got my negative there. Now I got to balance my electrons, so times by 2. Add all that together, and my net voltage is negative 0.089 volts. This is a negative voltage, which means this will not produce electricity. It requires electricity. In fact, I have to crank my little dial to 0.89 volts just to get to zero, right? Just to break even. And then if I crank it a little bit more, then this reaction will start to work. This is non-spontaneous. You arrange them, it doesn't just happen. You can arrange everything perfectly, nothing will happen. We gotta force it to happen by pumping electricity into there. Okay, now let's look closer at the oxidation reaction. Waters are giving up 4 electrons. So those two waters will give up their 4 electrons. Now that's a little simplistic view, the electrons go, into the wall and whatever. Anyway, they follow the pathway of the wire and we get there. So electrons still flow anode to cathode. We have made some acid at the anode. One of the products was H positive. So this solution will become more acidic. In other words, the pH will drop, right? We also made some oxygen. So little oxygen bubbles are going to get produced on this cathode. Okay. All right, now let's look at the copper reaction. So I know that my SOA is copper 2. They grab 2 electrons, and then they form copper solid. And so what we see happening is all of a sudden the key starts getting plated with copper. Anions still migrate to the anode, and cations still migrate to the cathode. All right. That's it. That's how this works. We're going to show you one other thing here. This is going to be the electrolysis of water. So what I have is 2 test tubes filled with water. They're upside down, and they're also connected to this power supply by wire. And at the end of these wires are little pieces of platinum. Platinum is an inert electrode, which doesn't react. So the platinum will not be the SOA or the SRA, but it does allow electrons to pass through it. It's a pathway. It's a road. My cathode is connected to my negative post. So there's my anode. And all this is water and sodium hydroxide. Okay, I list my entities. I did list platinum there, but it won't be the SOA or the SRA. Excuse me. Okay, so my strongest oxidizing agent gets reduced, gain of electrons, reduction cathode. So let's write down my cathode reaction, which is reduction. Negative 0.83 volts, good. Strongest reducing agent, I go find hydroxide on my chart. It gets oxidized, that's my anode reaction. All right, and I flipped the reaction, I flipped the sign. Okay, I add everything together after I balance. And I get all of that, negative 1.23 volts. And then if you'll notice, I can actually cancel my hydroxides. I can cancel a couple of waters there, which cancels 2 over there. So my net reaction is 2 waters form 2H2 and O2. In other words, I have just split water into its elements, hydrogen and oxygen. And notice that this is called the electrolysis of water. Okay, all right. Let's examine the reaction. Look what happens here. 4 hydroxides are throwing away 4 electrons. Okay, so away they go. They go anode to cathode, pile up on the platinum on the other side. I am also making oxygen at that electrode. So little oxygen bubbles are going to start appearing. And I'm making some water over there. Okay, at the cathode, notice that the waters are grabbing, there's 4 waters, they're grabbing a total of 4 electrons. And I'm making some hydrogen gas. But notice I times my hydrogen reaction by 2. So for every 1 oxygen bubble, I get 2 hydrogen bubbles. Okay. And then I make some hydroxide over there as well. Now over time, here's what we would see. We would see a 2-to-1 ratio happening. 2 hydrogens for every 1 oxygen, right? And you can see that in my balanced equation at the bottom. 2 H2Os make 2 H2s and 1 O2. Okay? All right, there you go. That is the electrolysis of water. Okay, some work to do. Thank you very much.